The formation of the Earth was initiated 4.6 billion years ago. To conceptualize such an incredible amount of time, geologists break down the geologic time scale into smaller chunks, represented by eras, which are further subdivided into periods. Then the periods are also subdivided into epochs, and so on. This breakdown of the geologic time scale was done according to the prevalent environmental conditions and geological processes which dictate the sorts of biological species, geological formations, and their structures, in addition to the type of weather and climate that prevail at a specific period of time. As these controlling factors change with time, and we're talking super long periods of time here, a change in the Earth in terms of both shape and composition and its inhabitants is definitely going to follow. Therefore, geologists were able to put boundaries between those different paleo-environments, so that each of which represents a certain time span. The longest geologic time unit is an eon that comprises several eras, then an era which consists of periods with their yet smaller subdivisions, which are epochs. The first eon of the geologic time and the oldest is the Hadean, spanned from 4.6 to 4 billion years, during which the Earth was a hostile place with no continents, ubiquitous volcanism, and frequent asteroid impacts. Given this description, it seems appropriate to call this eon the Hadean, which is derived from the Greek word Hades, meaning the underworld or the god of the underworld, and hence a fitting comparison to such a hellish landscape. A particularly significant event is believed to have taken place 4.4 billion years ago, when a Mars-sized protoplanet named Theia slammed into the Earth, creating a worldwide magma ocean and producing the tilt in the Earth's rotational axis in the process. Though the Earth and Theia mostly coalesced, the impact caused parts of the crust and mantle of both planets to be ejected into the space, generating a ring of debris which collected to form the Earth-Moon. After that, the Earth started a slow journey toward more calm conditions as protocontinents and oceans began to form. Such extremely harsh conditions of the Hadean likely hindered any development of life. Moreover, no rocks of this eon exist in the rock record, simply because all the rocks are more likely to be destroyed or altered by geological processes. The only surviving terrestrial materials from the Hadean are zircon crystals, which are durable and can survive processes like subduction and weathering. All in all, the Hadean is considered the most mysterious eon in the history of the Earth. The next eon is the Archean, lasted from 4 to 2.5 billion years. The tapering of heavy asteroids, bombardment, and the subsequent emergence of life are important characteristics of this eon. The oldest terrestrial rocks as well as fossils belong to the Archean. The oldest fossils are 3.48 billion years, namely stromatolites, which are the rocky remnants of microbial mats formed by cyanobacteria. This suggests that by the Archean, single-celled life was already flourishing on Earth. Another main event during the Archean is the formation of large continents. Remnants of these ancient continents are called cratons and are found mainly in Canada, Africa, and Australia. These cratons were formed via accretion of many smaller microcontinents as they collided along ancient subduction zones. By the end of the Archean, the Earth looked more or less like it does today, having oceans and large continents with rivers and lakes, but it's still very different from the Earth we know. Its atmosphere back then, for instance, was 100,000 times less oxygen than the air we breathe today, and instead containing large amounts of carbon dioxide and methane. Life was also exclusively unicellular and would continue to be so for at least an additional billion years. Next comes the Proterozoic Eon from 2.5 billion years to 541 million years, which began with a gradual increase in the amount of atmospheric oxygen generated by newly evolved cyanobacteria with photosynthetic capabilities. As the amount of oxygen increased, thick deposits of iron oxides known as banded iron formations precipitated on ocean floors. This concentration of oxygen, however, caused the extinction of obligate anaerobes, which are organisms that are poisoned by oxygen. This event is called the Great Oxidation Event or the Great Oxygen Catastrophe. Moreover, the sky and oceans shifted from orange and green tinted to the blue we see today. Unicellular eukaryotic life, as well as the first multicellular life, evolved during the Proterozoic. The Proterozoic was also a time of supercontinent formations. Converging continents collided to form the first supercontinent, Nuna, around 1.8 billion years. However, around 1.5 billion years, convection currents in the mantle changed directions, causing Nuna to break apart or rift. The assembly and later breakup of supercontinents is a cycle that was to repeat an additional 2 times in Earth history, with another cycle occurring later in the Proterozoic with the formation and breakup of Rodinia between 1.1 billion years and 750 million years. The first 3 eons, the Hadean, Archean, and Proterozoic, are commonly grouped together as a one supereon called the Precambrian supereon. Here comes the Phanerozoic eon from 541 million years to the present, which consists of 3 main eras with their respective periods and epochs. The first era is the Paleozoic, spanned from 541 million years to 252 million years. and it began with the Cambrian explosion, which was a short period of time during which life evolved tremendously. Animals that lived in the Paleozoic included marine life such as trilobites, fish and sea sponges, as well as land animals like amphibians and reptiles. In addition to the evolution of plants, especially during the Carboniferous period when large deposits of coal were formed. Major geologic events of the Paleozoic are the breakup of Pangaea and the formation of Pangaea, with some organic or mountain building events. The Paleozoic ended with the Permian extinction, which is the largest extinction event in Earth's history, and after it, only 10% of life remained. Scientists have many theories as to what caused the Permian extinction, including asteroid impact, volcanic eruption, lack of oxygen, and global warming. Moving on into the Mesozoic era, aged 252 to 66 million years, which includes the Triassic, Jurassic, and Cretaceous periods. After the great extinction of the Permian period, many new kinds of animals evolved during the Mesozoic. For instance, the first dinosaurs, marine reptiles, lizards, and tortoises appeared, in addition to crocodiles, which were abundant, and insects attained complete metamorphosis. And later on, still within the Mesozoic, birds diversified and expanded in numbers, and they may have been the reason that flying reptiles decreased significantly. Giant plant-eating dinosaurs roamed the planet, with smaller but vicious carnivores stalking on them, and creeping about in the undergrowth were tiny mammals no bigger than rats. In terms of plant life, conifers, cycads, and ferns were common. However, the most significant advancement during the Mesozoic was the appearance and rapid diversification of the first flowering plants, and consequently many modern groups of insects appeared and began to diversify, including ants, termites, bees, butterflies, aphids, and grasshoppers. As for the geology, the same forces that formed Pangaea began to pull it apart and gradually developing rift basins with active volcanism along the axis of these rift basins. These rift basins later became the Atlantic and the Gulf of Mexico. Moreover, other rifts later split off Antarctica and Australia. The Atlantic Ocean continued to lengthen and widen, particularly to the south, which split South America from Africa. India separated and became an island continent. Much of each continent was covered with shallow continental oceans and inland seas. North America, Europe, Asia, and Africa became a series of inlands. The Mesozoic ended with a massive meteorite impact that caused a mass extinction, wiping out the dinosaurs and up to 80% of life on Earth. And here is the era of modern life, the Cenozoic, spanning from 66 million years ago to the present, and it is called the Age of Mammals due to their rapid and intense radiation thanks to the end Cretaceous mass extinction that killed off their competitors, the dinosaurs. By the Cenozoic, all Earth's continents were close to their current locations except for India, which was approaching Asia. Then later on, collision and orogeny occurred around 50 million years ago. This event initiated the uplift of the Himalayan mountains and is happening to this day. Then Antarctica became an isolated continent around 34 million years ago as Australia and South America broke off and moved northward. This led to the development of cold ocean current around Antarctica, helping trap colder air over the continent. The development of the so-called circumpolar ocean current led to global cooling and the development of the first permanent Antarctic ice sheet, marking the beginning of the modern ice age. The next major change is the development of glaciers in the northern hemisphere around 2.6 million years ago, and the cause of which is still debated. Now, just another perspective for a better comprehension. If all of Earth's history was squeezed into one calendar year, the Precambrian super eon would last for 10 months, the Paleozoic would span 44 days, the Mesozoic would take 11 days, and the Cenozoic would only be a 5-day span. In this scale, the modern ice age, which began 2.6 million years ago, would have begun just 1 minute before the end of the year. As for all of the recorded human history, it would have taken place within the last 5 seconds of the year.